Here's the second set of notes to finish out the notes on the front side of the molar solutions and titrations handout and practice problems. So to reach an equivalence point in a titration, or the neutralization point, between an acid and a base, the number of hydrogen ions must equal the number of hydroxide ions. So let's remember our titration equations and the T-chart, so we'll rewrite those out. So to find the unknown acid molarity, we're going to take the liters of our base, and then we're going to multiply by the molarity of our base, we're going to multiply by molarity, and then we're going to leave liters of acid on the bottom. So just a reminder, that first section is the molarity of the base, and the second section is molarity. So go ahead and pause the video so you can rewrite that T-chart onto your notes here. Okay, so hopefully you paused the video and got that T-chart down. Another helpful T-chart is going to be to find the unknown acid volume. So when this happens, we will actually know the molarity of both the acid and the base. And so what we'll do is start with what you know the most about. And so we'll know the most about the base, we'll know the volume of the base and the molarity of the base. And we'll be able to use the molarity of the acid as well as molarity to calculate for the volume of the acid, because we'll be left in liters at the top. So again, we'll use this when we have both acid molarities known. So go ahead and pause the video to make sure that you can get that down as well. Okay, so hopefully you paused the video there. I'm going to do number 3 with you, and the rest will be your responsibility. So number 3 just says a 15.5 ml sample of a 0.215 molar KOH solution required 21.2 mils of aqueous acetic acid solution in a titration experiment. Calculate the molarity of the acid. So if I have my balanced chemical equation, I'm going to read and look at what I have the most information about. I have my volume of my base, and I have the molarity of my base. I only have the volume of my acid. So when that happens, I'm going to use my T-chart that guides me towards finding the unknown acid molarity. So if I have more information about the base, I'm going to start with that information. So I'm going to start my T-chart here, and I need to make sure that I have a balanced chemical formula. So in this case I give it to you, but in other problems I do not. So you need to make sure that you have a balanced written reaction out there. So first thing I'm going to start with is my given, so my 15.5 mil sample of KOH. So I know that mils of KOH need to go on the bottom, and I know because I'm using the molarity of my base I need to get to liters. So I'm going to go to liters of KOH, and then I know 1 liter is 1,000 milliliters. So then I'm going to continue my T-chart, and I know that liters of KOH go on the bottom, and I know that I need to get to molarity of an acid, which means I need to end with moles of acid on top. The only way I can do that is to get to moles of base first, and I can go from liters to moles because I have the molarity in my problem. So I know that 1 liter is 0.215 moles. So again, I know I need to get to moles of acid on the top, so I know moles of base need to go on the bottom, and then using molarity, I can go to moles of acid on the top. So again, that's why we have that balanced chemical formula, and in this case it's a 1-to-1 ratio. And then lastly, what we want to think about is, because we're trying to solve for the molarity, we want to make sure we don't cross out moles of acid here. If I were solving for volume, for example, right here, I might put moles of acid down here, but in this case, I'm solving for molarity, so I want moles of acid over the liters of acid, so that's what goes right there. There's 2 different ways that you can approach this. You can show me your conversion from mils to liters within your T-chart, or you can simply just put in the liters of acid into your T-chart. So if I look at what I can cross out my mils, I can cross out my liters, I can cross out my moles of base, and then I'm left in moles of acid over liters of acid, which equals molarity. So go ahead and pause the video and calculate that out. Okay, so hopefully you calculated that out and that you were able to get 0.157 molar acetic acid. So that's how you would say that, 0.157 molar acetic acid. So as we move on, the rest is your responsibility, but some things to look out for. Okay, number 5, make sure that you write your balanced chemical formula there before you start, because you'll need to go through molarity and use that. And then please watch out on number 7 that when you have a diprotic acid, your mole ratio is probably going to be adjusted ever so slightly. So please watch out for that. The rest of this is your responsibility. Thank you.